So graphs of circles. We're going to be focusing on doing problems. There's just one little thing I want to mention before we jump into it, and that's the standard form for the equation of a circle, because we're going to be using this formula in every problem that we're going to be going over. It's really good to know this formula for these types of problems. So the standard form for the equation of a circle with center hk and radius r is x minus h squared plus y minus k squared is equal to r squared. Okay, and you can see a picture of a circle here with center hk, the radius is r, that point xy is just some arbitrary point on the circle, and you can see that the distance between the center hk and an arbitrary point xy on the circle is r, and that's where this formula comes from. Those of you who know the distance formula will recognize that this is really the same as the distance formula. You probably use different letters in the distance formula, but here you can see that r is just the distance between the points x, y, and hk. Anyway, let's jump right into some problems now. Okay, so the first one, in the standard xy coordinate plane, let C be the center and let R be the radius of the circle with the following equation. X minus 3 squared plus y plus 5 squared is equal to 7. Which of the following gives the correct values for C and R? All right, so remember I said we're going to be using this formula for the standard form for the equation of a circle. So I'm just going to write that down again here. X minus h squared plus y minus k squared is equal to r squared. And I'm just recopying the given equation right under that one so we can compare and see clearly that h is equal to 3 and k is equal to negative 5. Notice it's negative 5 because we have to take the opposite sign there, right? Because y plus 5 is the same as y minus negative 5. Let's just replace that so you could see it clearly, right? Okay, so that means that the center of the circle is the point 3, negative 5. So given that, that narrows down the possible answer to just choices A and B. We could eliminate C and D because they have the wrong center. Okay, now let's look at the radius. Well, we have that r squared is equal to 7. So from that, it follows that r is the square root of 7. And therefore, the answer is choice A. Okay, it's worth taking a quick look at a picture of this circle. You see that to plot the center of the circle, we move to the right 3 units and then down 5 units. The radius is root 7, which is a little bit less than root 9 or 3, right? 3 would be here, so it's a little less than that. So the circle is going to come a little short of going to the y-axis there. Next question. Which of the following is an equation of the circle in the xy plane that has center 0, 0 and radius 5? Okay, once again, let's look at that standard form for the equation of a circle. Okay, x minus h squared plus y minus k squared is equal to r squared. And we could just go ahead and pop the center in there. H is 0 and k is 0 to get x minus 0 squared plus y minus 0 squared equals r squared. And we might as well just simplify that, right? We don't need to write those zeros. We could just write that as x squared plus y squared equals r squared. Okay, and well, the radius is 5, so let's just go ahead and put that 5 in, and 5 squared is 25, so that gives us an answer of choice C. All right, in the xy plane, which of the following is an equation of a circle with center 5, 0 and a radius with endpoint 3, 1/2? Okay, let's put down the standard form for the equation of a circle. X minus h squared plus y minus k squared equals r squared. We're going to plug the center in to get x minus 5 squared plus y minus 0 squared equals r squared. Okay, again, we don't need that 0 there, right? All right, now we could cross out choices A and C because those have x plus 5 squared, and we narrowed it down to answer choices B and D. Okay, now we know that the endpoint of a radius is 3, 1/2. That means that the point 3, 1/2 lies on the circle, And so if we plug that point in, it will satisfy this equation. So we go ahead and plug in a 3 for x and 1/2 for y. And we have r squared is, I'm just recopying, 3 minus 5 squared plus 1/2 squared. Now 3 minus 5 is -2. And the square of -2 is 4. And the square of 1/2 is 1/4. Let's get a common denominator. 4 could be written as 16 over 4. Add 1/4, and we get 17 over 4 for r squared. Now, that gives us an answer of choice B. So be careful here. Remember, the right-hand side of the standard form is r squared, right? So this number has to be r squared, not r. So a common mistake would be to take the square root of this and put r here. But remember, in the equation, it's r squared, not r. What is the radius of the circle in the xy plane that has 2, 7 as its center and contains the point -10, 2? Okay, once again, I'm going to write the equation of a circle in standard form. X minus h squared plus y minus k squared equals r squared. We're going to go ahead and plug in the center for h and k, 2, 7. So we have x minus 2 squared plus y minus 7 squared is r squared. Okay, and it contains this point, -10, 2, which means that we could substitute that point in to the equation, and we get a true statement. So in place of x, I'm going to put -10. In place of y, I'm going to put 2. And we get -10 minus 2 squared plus 2 minus 7 squared is r squared. Okay, so just rewriting that with the r squared on the left. -10 minus 2 is -12, and 2 minus 7 is -5. The square of -12 is 144. The square of -5 is 25. And when we add those up, we get 169. Now the question's asking for the radius, r. So r is the square root of 169, which is 13. Okay, and that's the answer to the question. A circle in the xy plane has equation x minus 2 squared plus y plus 4 squared equals 36. Which of the following points does not lie in the interior of the circle? Okay, so this time I'm essentially writing the standard form of the equation of a circle, but instead of writing it as an equation, I'm writing an inequality, right? Because we want it to not lie in the interior, which means that instead of x minus 2 squared plus y plus 4 squared being equal to 36, we want it to be greater than or equal to 36, right? Because if you were in the interior, it would be less than 36. Since it's not in the interior, it should be the opposite of less than, which is greater than or equal to. Okay, so I'm just going to go ahead and take choice C as my first guess, plug that point in and see if it works. So I'm replacing x by -2 and y by 1. And we get -4 squared plus 5 squared is greater than or equal to 36. Or 16 plus 25 is greater than or equal to 36. And that simplifies to 41 greater than or equal to 36, which is true. Therefore, choice C is in fact the answer. In the xy coordinate plane, what is the radius of the circle having the points 2, -4 and -4, 4 as endpoints of a diameter? So this time we're not given the center. So I'm going to go ahead and find the center by taking the midpoint of the line segment that passes through those 2 points, 2, -4 and -4, 4. Right? Because those 2 points are endpoints of a diameter. So right halfway between them is the center. And we could get that by simply averaging the coordinates. If we average 2 and -4, or take 2 minus 4 and then divide that by 2, we'll get the x coordinate of the center. And similarly, if we add -4 and 4 and divide by 2, we'll get the y coordinate of the center. Now, just to simplify this a little, 2 minus 4 is -2, and -4 plus 4 is 0. So we get that the center is -2 over 2, which is -1, and 0 over 2 is 0. Okay? So once we have the center, we can now, once again, using the standard form for the equation of a circle, replace h and k by -1 and 0. And once again, be careful. X minus -1 is the same as x plus 1. And when you plug in the 0, you don't actually have to write the 0 if you don't want to. Okay, now I'm going to go ahead and plug in one of the endpoints of a diameter. I could use either one because they both lie on the circle. I'll just choose the first one, which is 2, -4. When I plug in the 2 for x and the -4 for y, let's see, we have r squared is 2 plus 1 squared plus the square of -4, which is 3 squared plus the square of -4, which is 9 plus 16, or 25. And we're being asked for the radius, so we have to take the square root of 25 to get 5, and that is the answer. Okay, I want to go through a couple other ways to do this particular problem. So let's do this a nice graphical way also. I'm going to start by plotting the 2 points in the xy coordinate plane, 2, -4. So we could get 2, -4 by going right 2 and down 4. And we get the point -4, 4 by going left 4 and up 4. Okay? And we're basically looking for the radius of this circle. Now, I drew this circle just so that we could see it. We don't actually need to draw that to solve the problem. I just thought it'd be nice to see what we're actually looking for. Okay, so now I'm going to go ahead and turn this into a right triangle. So a right triangle with a hypotenuse has endpoints 2, -4, and -4, 4. And notice that the length of this leg is 6, right? How do I get that? Because it's going from -4 to 2, right? -4 to 0, that's 4, plus another 2 is 6. And this leg, the vertical one, has length 8, right? Because it's going from -4 up to 4. So there's 4 here and 4 here for a total of 8. And now we can, we could use the Pythagorean theorem to find the hypotenuse, but it's actually a lot quicker if you happen to know the Pythagorean triple, 3, 4, 5. Then we could go ahead and double those numbers to get another Pythagorean triple, 6, 8, 10. And we see that the length of the hypotenuse is 10. Now that is the diameter of the circle. See? But we want the radius of the circle. Always be careful to go back and look for what the question is asking. So the radius is half the diameter, which is 5. And one more method, the quickest one. If you happen to know the distance formula, then we can just go ahead and plug all the numbers given there into the distance formula, right? So using the distance formula, d is the square root of c minus a squared plus d minus b squared, where we have the points a, b, and c, d. So a is 2, b is -4, c is -4, d is 4. We can go ahead and plug those numbers in, right? So we have -4 minus 2 squared plus 4 minus -4 squared. And let's see, -4 minus 2 is -6. 4 minus -4 is 4 plus 4, which is 8. So we get the square root of 36 plus 64, which is root 100, or 10. That's the diameter of the circle. Once again, we want the radius of the circle, so that's half the diameter, which is 5. Okay. In the standard xy coordinate plane, let c be the center and r the radius of the circle with the following equation. X squared minus 8x plus y squared plus 10y plus 15 is equal to 0. Which of the following gives the correct values for c and r? This time, the equation that we're given for the circle is not in standard form. It's in what's called general form, which isn't as useful because in the general form, we can't easily pick out the center and radius. So what we're going to want to do is change it to standard form. Okay, so I'm just copying the equation down one more time, and we're going to go ahead and use a method called completing the square. So what we do is we start by taking the coefficient in front of the x, which is -8, and we cut it in half. So whatever that number is, we take half of it. In this case, we get -4. And then we square that number to get 16. And we're going to do the same exact thing with the coefficient of y. We're going to have that 10 to get 5, and then square that number to get 25. Now, these two numbers, 16 and 25 that we got, we're going to add them to each side of the equation. So notice that we had x squared minus 8x, and then I'm going to put plus 16. And since I added that to the left side of the equation, I also have to add it to the right side of the equation. Similarly, then I have y squared plus 10y, and I'm going to add the 25 next to it. And since I added it to the left side of the equation, I also have to add that number to the right side of the equation. And at the same time, I did one more thing. I took this 15, this constant, and I brought it over to the right by subtracting 15 from both sides of the equation. See, I brought it over here. It's on the right-hand side now. Okay, now, on the left-hand side, what we wind up with are two perfect squares. X squared minus 8x plus 16 is a perfect square, and y squared plus 10y plus 25 is a perfect square. In fact, x squared minus 8x plus 16 factors as x minus 4 squared. Okay, now you could do that factoring by hand if you know how to factor, but this number is always equal to this number here, that first number we got when we took half of this. You could always just pop that in there. Similarly here, we always get the 5 here. Again, you could factor this by hand, and you'll see that it's equal to y plus 5 times y plus 5, which is y plus 5 squared. But if you do enough of these, you start to realize, oh, it's just this number that goes in there. And now where did this 26 come from on the right? Well, we just added all these numbers up, right? Negative 15 plus 16 is 1, plus another 25 is 26. So what we have here now is an equation of the circle in standard form. And from that, we could pick out that the center is 4, -5, and the radius is root 26, and that is choice B. The equation of a circle in the xy plane is shown below. What is the radius of the circle? Okay, so the circle has equation x squared plus y squared minus 4x plus 6y equals -9. Once again, it's not in standard form. So first thing I'm going to do is just move the x's next to each other and the y's next to each other. So notice I moved the -4x to the left of the y squared, and that puts all the x's here and the y's here. The constant is already on the right-hand side. That's good. That's where we want it. Now I'm going to complete the square again. Half of -4 is -2. When we square -2, we get 4. Half of 6 is 3. When we square 3, we get 9. Okay, so we're going to add 4 to each side of the equation, and we're going to add 9 to each side of the equation. Once again, x squared minus 4x, and then we add the 4. And then we do it to the right, and we have y squared plus 6y, and we add the 9, and we also do that to the right. So on the left, we have two perfect squares. X squared minus 4x plus 4 factors as x minus 2. The -2 comes from right here. And y squared plus 6y plus 9 is y plus 3 squared. The 3 comes from right here. And on the right, we just add these up. The -9 and the 9 cancel, and we're left with 4. The equation of this circle is now in standard form. And this here, the 4 represents r squared. So r is the square root of that, which is 2. And that is the answer. Notice in this question, I have a little asterisk over there. That asterisk just indicates that we're going to need a calculator to do this question. Okay, all the other questions, we didn't need one. All right, so the graph of x squared minus 7x plus y squared minus 13y minus 14 equals 0 in the xy plane is a circle. To the nearest tenth, what is the radius of the circle? Okay, so I just rewrote the equation, and we're going to go ahead and complete the square. This time it's a little messier because there are fractions. Half of -7 is -7 halves. When we square that, we get 49 over 4. Right, because 7 squared is 49, and 2 squared is 4. Similarly, for y, half of negative 13 is negative 13 halves. And when we square that, we get 169 over 4. So these are the two numbers we're going to add to each side of the equation, right? So nothing different. The numbers are just a little messier. So we have x squared minus 7x, and then we add 49 fourths. We do it here and to the right. And over here, y squared minus 13y, and then we're going to add 169 fourths, and we add it to the right as well. And notice I also brought the negative 14 over. I have to add 14 to each side, so it becomes a positive 14. Okay, so once again on the right, we have x minus 7 halves squared, right? This number just goes here. This is the negative 7 halves. And y minus 13 halves squared equals, and here I'm just adding all these up using my calculator. No special skills required. It's a calculator problem. We can just add them up using the calculator. Okay, so r squared is 68.5. So r is the square root of 68.5, which when you put it in your calculator is about 8.276. And to the nearest tenth, right, we want it to the nearest tenth, that's 8.3. We round the 2 up because there's a 7 after the 2. And that is the answer. Okay, this is another calculator problem. Whenever I put the star there, I mean you will need a calculator to do this. In the xy plane, the graph of 3x squared minus 12x plus 3y squared plus 30y plus 71 equals 0 is a circle. To the nearest tenth, what is the diameter of the circle? Again, this one is not in standard form. It's in a general form. But worse than that, it has a 3 multiplying the x squared and a 3 multiplying the y squared. We can't complete the square unless there are no numbers here, meaning there's a coefficient of 1 or nothing appears there. So to rectify this, I'm just going to divide the whole equation through by 3, right? 3x squared over 3 is just x squared. Negative 12x over 3 is negative 4. 3y squared over 3 is y squared. 30y over 3 is 10y. And 71 over 3, I just leave as 71 thirds. And finally, when you divide 0 by 3, you just get 0. Okay, and now I'm going to complete the square. Half of negative 4 is negative 2. The square of negative 2 is positive 4. Half of 10 is 5. When you square 5, you get 25. So I'm going to go ahead and add 4 to both sides of the equation. I'm going to add 25 to both sides of the equation. And I'm also going to bring the 71 thirds over to the right by subtracting it. Okay, and then we have x minus 2 squared. The negative 2 comes from here. Plus y plus 5 squared. The 5 comes from here. And I add all these up in my calculator to get 5.333 approximately. So r squared is about 5.333. I take the square root in the calculator to get about 2.309. And we want the answer to the nearest tenth. So before that, oh, right, we want the diameter. So the diameter is 2 times the radius. So 2 times 2.309 is 4.6188. And again, we want the diameter to the nearest tenth. So that becomes 4.6. And that is the answer.